Yeah, I'm Bob Kleinberg. This is the second talk I've given in the Meta series. Perhaps some of you remember last fall I talked about something really quite different, global warming potential, and it was kind of full of physics. Much less physics here, although you'll see a bit. What I'm talking about is methane emission controls and basically focusing on the recommendations I'm going to make to the Environmental Protection Agency, and this is sort of a dry run of that. I've just finished a 31-page treatise that I'm going to submit in the comment docket. This is a half-hour summary of high points, I'd say. So you're not going to get the whole thing, but you'll get a flavor of it, and certainly any feedback you might have will be gratefully received. Better to get it before submission than after. So just to get the ball rolling, so almost the first thing that President Biden did after being inaugurated on the Capitol, he drove to the White House and signed Executive Order 13990. That was the executive order dealing with the environment and climate change. And an important provision of that, let's see if I can just get rid of, there we go, was a directive to the Environmental Protection Agency. And he directed them to propose new regulations and emission guidelines for methane and volatile organic compounds from existing operations in the oil and gas sector by September of 2021. So pretty short timeline, President Biden. You gave your bureaucrats about 8 months to throw together some sort of plan for better methane regulations, which of course we're all interested in. So EPA sort of jumped on it, and in the middle of May, they announced a series of what they call listening sessions, and this is both verbal and in writing. This is very unusual. By law, agencies have to receive comments on proposed rules and regulations. Normally that's done after the regulation is written. And human nature being what it is, agencies are very reluctant to make any big changes in the regulations that they have so carefully crafted over the previous year. So a lot of the suggestions get ignored. I mean, politely, but ignored. This time, they're asking for comments before they write the regulations, which strikes me as extremely open-minded. And I think many people intend to use this to best advantage and try to have some input into what the new rules are going to say. On the bottom line here of this slide, you can see the web address where you can submit your comment and the docket number. I have sent these slides to Evan already, and he will distribute them to attendees and whoever else is interested. So you don't need to write down every number. You can also contact me directly. So just a very quick look at history of regulatory actions with respect to methane. It's been a busy field. Basically, back in 2012, EPA promulgated rules on volatile organic compounds and sulfur dioxide. That was called Quad O in the parlance. And that sort of established natural gas emission regulations in more or less their present form. It was updated 4 years later in 2016, again during the Obama administration. Quad OA is the slang for the regulation. And that extended the regulation to greenhouse gases and in particular to methane. Trump came along and had to tinker with it. So he didn't like greenhouse gases and the attention on methane, so those things were deregulated. And that happened of September last year. And just last Friday, the the House of Representatives concurred with the Senate to reverse that deregulation in the Congressional Review Act. And Biden will sign that any minute now. I mean, it might actually have been today, although I'm not up on the news, but certainly real soon. So my comment with respect to all this is that the amendments that were promulgated in 2020 that reversed the methane regulation that's now been reversed again, did not have time to take effect. But merely reverting to the status quo ante by use of the Congressional Review Act will not improve industry's environmental performance relative to current trends. And so you might be wondering, okay, what are the current trends? So that's on the next slide. You can view the current trends either optimistically or pessimistically, depending on your point of view and your sort of personality. But let's look first to the left. This is a chart, years on the horizontal axis from 1990 to the present. This is all EPA data. Now, using emission factors. Now, many of us don't like emission factors very much, and there's been plenty of work showing that emission factors systematically underestimate the amount of methane emissions. However, if you want to look at a long-term time series, EPA is really the only game in town. They have been carefully curating their time series records for methane emissions for 30 years. And so if you just want to look at trends, that's where you go. So that's where we're going. Now, the vertical axis on the left is methane emission intensity, and that is the amount of methane emissions from oil and gas infrastructure divided by U.S. gas production. And the U.S. gas production all by itself is shown in red and on the right-hand scale. Now, there's a major feature in these two lines on the left, and there's a big break at about 2006. That was the advent of hydraulic fracturing, massive hydraulic fracturing, the fracking revolution, if you will, where gas and oil production both really took off in the US. So what you're seeing is a black curve, which is methane emission intensity, and a red curve, US gas production, which are mirror images of each other. Now, the red curve is the denominator of the black curve. What this tells me, even without going further, is that the numerator probably wasn't changing much. In other words, the actual methane emission. And that indeed is pretty much substantiated by the plot on the right. Again, looking at years from 1990 to the present, to the latest EPA data, I should say, which is 2019. And the vertical axis, which is on a very much expanded, exaggerated scale, and that's why the data looks noisy, but that's basically methane emissions divided by the methane emission in 2013, just for convenience. And what that trend shows is that we have been on a pretty steady but slow decline of methane emissions since 1990, with a compound annual growth rate of about minus 0.3%. Now, that's a little bit discouraging because in 2016, Obama promised in signing a treaty with Mexico and Canada that the US would slow down its oil field methane emissions by 6% per year, and we are getting a 0.3% per year decline. And moreover, and this is probably the most discouraging thing of all, is that it didn't change when all these regulations came in. Now, the 2012 regulation basically put in a lot of the regulations that were just continued in 2016 regulations. So we should have been seeing some action starting from 2012, 2013, and we are not. So my point of view is that, we've got all this regulatory machinery, some of which is pretty onerous, that kind of isn't working. It's encouraging that emission intensity has gone down from 2% to 1%, while US gas production was growing. That's great, but methane emission itself, not much happening. So the rest of this talk is to figure out why that's true. So first, let's look at leak detection and repair. And this is a subject we all love to talk about. Industry is sort of fixated on it because it's an ongoing expense and therefore an annoyance. And And the sort of the hardware guys and experimenters and so on love it because they get to try their new toys. Everybody likes looking for leaks. Unfortunately, not much has come of this, and it's kind of hard to say that. This is a kind of a big table. I'm not going to go through every box, but basically, leak detection and repair. These are estimates from EPA from 2016 projected to 2020 using the rules that they promulgated in their 2016 Quad OA rules. Basically, industry is spending $227 million a year on methane leak detection and repair. That's the EPA estimate. And for that, they're getting a methane emission reduction of about 170,000 tons per year. So here's the $227 million, and here's the 170,000 tons per year. Now, 170,000 tons, that sounds like a lot of tons, but not really, because what we're actually emitting is something like 8 million tons. So the entire EPA target for LDAR is like 2% of emissions. Like, really? We're going to all this work and paying all this attention and spending all this money for a 2% reduction in emissions? Wow, that's kind of discouraging. Now, it turns out that if you divide these numbers, you find that what we're spending is something like $1,300 per ton of methane avoided. That's pretty darn close to the social cost of methane computed by the EPA, taken from the Interagency Working Group back in 2016. So, basically it's cost effective, yeah. So I can't argue against that. But nonetheless, LDAR just isn't doing that much. I mean, I'm that's kind of inescapable, at least according to these EPA projections. Okay, so let's look at sort of another area of interest, and that is our good old friends, the pneumatic controllers. Now, 2 million tons a year. Now we're talking real, talking real emissions. That's about a quarter or a fifth of total oil and gas emissions. 2 million tons coming from these valves, pneumatic controllers. These are ubiquitous throughout the oil field. There's something like 1.7 million of them is shown in the chart on the left, where we have, again, years. And EPA tracks everything. I mean, they are a phenomenal data gathering organization. So this is years from 1990. This is number of devices from 0 to 2 million. And each colored bar is a different kind of pneumatic controller. And these things are gas actuated valves. Now there's 3 flavors. The red flavor, which is the high bleed. Now these valves leak gas all the time on purpose. That is, they are designed to do that. I'm not exactly sure why. And the red ones emit gas at a particularly high rate. The blue also emit gas all the time, but at a lower rate. And then the green are intermittent, and they only emit gas when the valve is changing state. Turned on, turned off, they emit a puff of gas. So basically, these valves are being driven by the pressure of the gas inside the line. That's actually convenient, especially when you don't have some place where you don't have power, because there's always gas pressure in the line. It's a good way of controlling the valve from a mechanical engineering standpoint. But you are emitting a heck of a lot of methane. So anyway, back in Quado, EPA came along and said, okay, no more high bleed valves can be installed. That was the rule. No more high bleed valves can be installed. And you can see that the industry had been swapping out high bleed valves anyway in changing over to low bleed and intermittent anyway. And here's where the rule came into effect. Okay, we're going to get rid of this kind of more of a step here. But they also, for reasons that are not entirely clear to me, also got rid of some of their low bleed valves and replaced them with intermittent. Now, what was the overall effect of that? So basically what you're seeing here, a picture, industry complies with regulation, okay? So the number of high bleed valves goes down. It's not so obvious on this scale, but it went down a fair bit. And replaced with what surely was the lowest cost replacement. That's how the oil field worked. And that's an area I've worked in for 40 years. So this is how things work. If you look over at what was the environmental effect, it was kind of discouraging, because although we got rid of a lot of emissions from high bleed, it turned out that the intermittent valves, although they sound like they should be better, aren't much better than high bleed. So what's the point? We've got this regulation. It's been on the books now for going on a decade, with no environmental benefit whatsoever. And this is very typical of how things work in the oil field. And I'm a loyalist. I mean, you know, I worked for Exxon, had a wonderful time there. I bleed blue for Schlumberger. But it is a fact that it says on the bottom line here, companies will comply with prescriptive regulation at lowest possible cost, always, regardless of the environmental outcome. And boy, that is written in big letters, in big headline letters right here on this slide. Let's look at tanks. Now, tanks actually have a performance-based regulation scheme, because if your tank emits more than 4 tons a year, you have to estimate how much your tank is going to leak, and you're only permitted to emit 5% of that estimate. So it's a performance-based limit. You sort of calculate what target you have to hit. You have to hit it. And EPA thinks that we're doing wonderfully well. So the EPA estimates for tank emissions right here, it's this little tan box that's like 100,000 tons a year. That's what they're estimating come from tanks. But David Lyon, who's on the call, will tell you that that is kind of pretty far off from the truth. And in this paper that just came out with Jeff and Evan and Arvin and Dave and Adam and a bunch of other people, said, no, it's not 100,000. It's more like 2.2 million tons per year. Again, we're talking about another 20 to 25% of total oil field emissions coming out of tanks. Now, the problem here is that although EPA mandated a procedure that should have been effective, there was no procedure for verifying compliance. You just give EPA your plan for reduction. You promise to implement the plan. You implement the plan. And what happens? Well, what happens, right? EPA marks it down on their spreadsheet as done. And we're emitting 2 million tons per year from tanks. So my conclusion is performance-based regulation depends on accurate measurement. And using emission factor methods to estimate how much you're going to get renders performance-based regulation worthless. That's a strong statement, but I'm kind of a measurement guy. Let's look at flares. I think most of you know this story, so I'm not going to dwell on it. EPA estimates from Permian Basin about 80,000 tons per year of methane. Basically, they're assuming that there's a lot of flares in the Permian Basin. Basically, they're assuming they're 95% efficient. That's the number they came up with back in 1996, and they're sticking with it. EDF has done some terrific surveys and found that no, it's not 80,000, it's actually 4 times larger. Now, and it's 4 times larger because there's lots and lots of malfunctioning and unlit flares as shown in the table. Now, you look back at EPA regulations on flares and you find some very interesting things. There's a smoke emission limit. Okay, great. There's a rule that every flare has to have a pilot light, and the pilot light has to be on and monitored. That's good. There's an upper limit on gas flow velocity inside the flare, and there's a lower limit on heating value. And those two things basically prevent the flare from self-extinguishing. Okay, all good. However, there is no requirement that actually detects unlit flares. There's actually no requirement that the flare be lit. Now you have to understand, you can never just shut off a flare. Flare is the ultimate safety tool in your whole gas system. If your pressure goes up, you do not want to blow up tanks. Absolutely not. So you've got to have a way of relieving the pressure, and that's the flare. However, you don't need fancy aircraft and even fancier satellites to find unlit flares. All you need is a combustion sensor that needs to be on the flare and monitored and in the right place. There's no such requirement, and guess what? People don't do it. So there is unlit flares all over the place. And unlit flares are some of the largest sources of methane on Earth. So my conclusion here, bottom statement, it makes no sense that current EPA regulations command finding methane leaks as small as 30 grams an hour, but ignore unlit flares that can emit 3 tons per hour. 30 grams per hour versus 3 tons per hour. Where should we be spending our time and resources? Okay, it's a good question. So now we're sort of getting to, okay, what do we do? That's that part of the talk. Now, if you've been listening, you've probably already absorbed the fact that broader society has really no interest in the kinds of valves used in the oil field. They really have no interest in what sort of gizmos you put on the tank to prevent them from emitting gas. They don't really even care about combustion sensors on flares. The broader society is concerned with how much methane is being emitted by the oil and gas industry, full stop. So what kind of regulations do we need to assure our population that we are not emitting methane from the oil and gas industry? Well, so I've got 2 columns here, prescriptive regulation and performance-based regulation. So on the prescriptive regulation side, there's a focus on components. There's a lot of interest in detecting tiny, leaks from flanges and valves and stuff. And I've done this myself with Drew, and it's frustrating and kind of ridiculous. You're looking for 30 grams per hour, which is like a pilot light on a hot water heater. Okay, just to give you a sense of that. Now, because these regulations are prescriptive, there are separate rules for leaks, vents, and flares. They're all different, they're disconnected, and you just got to comply with them all. The regulators write the rules, okay? It's a rule book that is complied with. Industry will comply, but they will only comply with the rules that are written down, and they're not really looking for the results of those rules. Measurements are not required, and there's a good reason for that. When EPA wrote Quad O and Quad OA, measurements were pretty immature. We didn't have the kinds of field studies that we are now accumulating at a very rapid rate. We didn't have the kinds of instrumentation that's been developed over the last 10 years. So not seeing them, they thought, well, measurements are not out there. We can't ask for them, so we're not going to require them. Therefore, compliance is essentially unverified. It's on the honor system. Now, I've worked for oil companies, and I can tell you oil companies comply. They do. They comply. It's an honor system, and I think it probably works fine in the US and Canada, but if you want to export these kinds of systems to other countries where the rule of law is maybe not in such good shape, then you're going to run into some issues. Okay. Now, and finally, suppliers are going to be rated pass-fail. Either you're going to get a checklist from EPA, you're going to tick all the boxes, and you're going to hand the checklist back. That's a pass-fail system. Let's look at the performance-based regulation side. Focus is not on components. It's on facilities or companies, and companies are the regulated entities. Basically, you want a system where companies worry about how they're doing at company level in terms of either paying fines if they're not doing too well, or maybe getting some reward if they're doing better than average. If you're going to be looking at facility level emissions, the kinds of sensors that we have, and the airborne, the trucks, the permanent sensors and so on, they can't tell the difference between leaks and vents and flares. I mean, I know Project Astra is working on it, but really that's a hard problem. Really, you're getting sums of those things. And therefore, it makes sense to write your regulations in terms of a unified target for all emissions. Then you tell the engineers, okay, you're emitting so much per hour, so many kilograms per hour from your facility. We don't know where it's coming from, and we don't care where it's coming from. You figure out how to make that number smaller. Now, I'll tell you from my own experience, petroleum engineers are really smart people. They're really very clever. And if you tell them what your objective is, and you make it worth their while by some sort of combination of carrots and sticks, the usual thing, they will hit the target. They will. Now, but you need to verify compliance, and that means accurate measurements are essential. And fortunately, we are getting more and more excellent calibrations. Some of them are done at Stanford University. Thank you. And METech and other places. And moreover, the measurements are not only going to be getting more accurate, they're also going to be getting better and better. And that means that we can up our game in terms of pushing down our allowed emissions as time goes on. Now, next point is compliance has to be verified by validated third-party measurements. To me, having worked in the service sector, it makes sense to have a single service company service an entire basin so that you can compare one company to another within the basin and therefore hand out the carrots and sticks accordingly. The validation, probably done by the Environmental Protection Agency. It's like the Bureau of Weights and Measures. They should be good at that sort of thing using the METech facilities and facilities like it, or what Stanford's been doing. So that's going to be your validation. And then if you have that kind of system, then suppliers can be rated quantitatively. And for those of you interested in certified gas, that's good, because buyers are more and more going to want to buy gas with a low greenhouse gas footprint, and suppliers are going to want credit for it. And that means quantitative company averaged measurements. So to me, the second column just embodies everything that we need to go for. Now, okay, is this possible? Yes. In fact, it's already being done. So this is from the EDF Permian Map website, permianmap.org. I highly recommend that you spend a pleasant afternoon there. I've spent many pleasant afternoons. There's an enormous amount of data. Dan Cusworth and coworkers have just published a big tranche of it on NESTL just in the last few weeks. Basically, what you're looking at is the Permian Basin in West Texas and Southeast New Mexico. Every dot is a methane emitter. My presumption is that every single dot is legal. In other words, everyone's complying with present regulations, which is a bit horrific. Now, Dan and coworkers using the Avarice NG system have gone around and quantified every dot. I mean, they bin it in these fairly large bins, but their measurements are actually far more precise than that. So the bins are different colors. They're above a ton an hour in some cases. These dots need to go away. These seriously need to go away. But the practicality of large-scale, quantitative, airborne remote sensing is now well established. Other people have done it. Kairos does it. Bridger does it. The people with trucks do it. This is not unique. So I think all we need to do is really unleash the tools that a lot of you guys have developed, and I think we'll be in pretty good shape. So just to sum up, methane emissions have changed little over the years following promulgation of the Quad O and Quad OA rules. Compound annual decline rate is about 0.3%, which is shameful, and it's indistinguishable from trends observed since 1990. We have done, our regulatory scheme has done nothing, in my opinion. Some very important sources of vented methane have been inadequately controlled by Obama and Trump era EPA. By and large, industry complies with regulations, they do, but without regard to actual environmental outcomes. Now, okay, there are exceptions, and some people on this call constitute those exceptions, but industry is very big, very diverse, thousands of operators. A lot of them are not doing all the things that you best actors are doing. Performance-based regulation, including quantitative compliance monitoring, would engage the talents of thousands of engineers, some of whom I know, encouraging them to solve problems using locally appropriate solutions rather than relying on a prescriptive checklist approach that cannot anticipate every eventuality. Finally, and sort of summing it up, instead of proposing patchwork amendments to the outdated and ineffective mechanisms of Quad OA, EPA must entirely rethink natural gas emission control. So with that, I'm going to conclude. My email address is here on the slide. Like I said, Evan has the full deck of slides that I hope he will distribute. And I'm looking forward to our conversation. So thanks very much.